Okay, you are given an integer, construct a permutation p of length and satisfying the following condition: pi minus okay is divided by I from every I. Okay, it can be proven. Okay, that's possible. Okay, so adjacent will actually, so value will be 1 2 3 4 5 6 divided by I. Okay, 1 is free actually for 2. Okay, I'm removing the adjacent will. I want something multiplied by 2 here, something by 3 4. If I do okay, AVS different is 2, at least 2. If I take 4, I plus 1. Yeah, removing that value. So I need something odd here. 5 1 4 2 3. Okay, it gives me 4, it gives me 3, it gives me, it should be something opposite. I can't get this value. Yeah, so I can get this one. So 6 1 5 4 3, I guess. So the difference, okay, it should be 6 1 6 1 2 5 3 4. So it gives me 5, it gives me 4, it gives me 3, it gives me 2, and it gives me 1. Okay, it was a unique question. Okay, for 4, 1 2 3 4, 3 uh, 2 1 makes sense. Where 5 5, where the second line went? Put 1 here. 4 3 2 1, yeah. Okay, came back. Okay, Cordell manages a row of n street at the schedule. Okay, I don't want to read that. You are given a binary string s where s equal to 1 indicate that ith street has been occupied by a student, and s0 indicate that it is free now. It is cordon that no two adjacent seats are occupied currently. Cordon needs to add more students until it is impossible to seat anyone else in the row. However, she wants to achieve the state with as few students as possible. You want to achieve the state. Korean rules one to students strictly forbidden from sitting next to each other. Okay. Your task is to calculate the minimum total number of students sitting when it is impossible. Number of seated when. Task is to calculate the minimum total number of students seated when it is impossible to seat anyone else in the row. Where seated are strictly forbidden for sitting next to each other. You are given something where s equal to 1 indicate s0 indicate that is free now. It is important that no two adjacent seats are occupied currently. Cordell needs to add more students until it is impossible to seat anyone else in the row. However, she wants to achieve this sit with a state with as few students as possible. Your task is to calculate the minimum total number of students seated when it is impossible to seat anyone else in the row. Okay, 1 1 for 5 1 2 3 4 5, so I'm skipping that one. Yeah, is it that? Oh, it has some ones. Okay, for this one I'm ignoring this two, so I have one here. So I have to put one here also. 1 1 2. I can put one here. 3. I can put one here. 4. Answer button says 5 0 0 0 0 1 0 0 0 0 1 1 0 0 0. Is it the total minimum or? Yeah, it's total minimum. Okay, so it's saying I can add at max 2 values. If I add here, I'm ignoring this two, also this one, and I ignore this two. So if I add here, that automatically is ignored. So I have to add somewhere here. So 1 2 3 4 5 6 fifth test case in the fourth third. Okay, it didn't explain that. Okay, let me think. One, two, three. I have only two, so it's 100% sure I have to add one here, no matter what. 2, 3, 4. There's 4 value, so I have to add something here. There's 3 value. I don't get it. More student until it's simple. Anyone in the row have a shape on storage. Few students possible. Okay. Minimum total number of students seated with it is impossible. Yeah, the question is fine. Answer is 3. This will ignores this too. This will ignores. Can I reseat anyone? No, she can't. She can not. The second line of is drawn by a string as of length and is equal to adjacent character are is going to adjacent character are both 1. Not to adjacent. Okay. I have to put 1 here. I have to put, let's see an example. In the third, in the fourth, answer is fixed. In the fourth test case, no extra student can be seated. In the third test case, can place 2 students at seat 1 and 4. It can be shown that 1 and 4. 1 and 4, yeah. But what about this one? 5. 5. 1, 2, 3, 4. 1, 2. 1, 2, 3. Oh, it has only 2 ones. So just what should I say? Okay. So I have to put 1 here. I have to put 1 here. I have to put 1 here. So total 5. So if I have some 1s and 0s, I can ignore them. I can remove them actually. Yeah, I can remove those positions easily and think them. No, I shouldn't. Yeah, I should think them and as individual strings, part of strings at least. Okay, 1 2 3 after every one element. uh, hmm, reset to 0. if if something has 0 0 from every one, I should mm, I making it 1 is not good. If I make it 1, okay, I can make the previous value 1. Oh, another thing. If si equal to 1, it will count. If si minus 1 equal to 0, Okay, it's not. I say minus 1 equal to, okay, that's not the case. Greater than equal to 0, then as I minus 1 should be 1. As I, if as I minus 1 greater than equal to 0, as I should be 1. Yeah. The count is fine. Then if Si, if it's 0 and previous not equal to 118, then Si and Si flag, Si flag, if Si, just okay, I'm doing it in a wrong way. If Si equal to 0, if I equal to 0, plus plus, else if Si minus 1 equal to 0, then also count plus plus. One, 3. I'm saying it's what I'm saying I'm making it 1 and saying if previous value isn't 0, then make current value equal to 1. One, 2, y2. Size of string is 1. One, 2. If n equal to 1, okay, it should be 0, it should be 1. There's a little bit chance I'll get work because my solution is little bit weird, I was gonna say, because I just did some assumption kind of stuff. Okay, you are given an array A of length n for an integer k. We call it piggy if and only if it is possible to sort A in non-decreasing order by performing the following operation an arbitrary number of time. Okay, for first select two integer ij such that ai minus aj greater than equal to k, then sort ai aj. You need to determine the largest piggy integer k if such that such an integer does not exist. Okay, I'll put -1. Yeah, I thought so we're gonna get whack, cause let's rethink stuff and let's do it. Okay, 0 0 0. Okay, if I have any one, just removing that and thinking this array, thinking this is the individual one is always optimal. So I have to put 1 1. So I have to find the number of zeros here. Okay, 1 1 can remove 3 zeros. Yeah, I have to find the number of zeros in that range. For any one, I'll -1 -1. I think that should be the way to solve it. My solution was, yeah, I know it shouldn't, it was a weird one. Plus plus I minus 1 greater than equal to 1 0. Then I should make a flag. Like I minus 1 equal to -1 else plus equal to +2. Okay, so val plus 2 divided by 3 and val equal to 0. Count plus equal to val plus 2 divided by 3. Yeah, this solution is gonna pass for 90% sure. I should have solved in this way. Okay, for C I can choose any ij, so the difference is at least k. Okay, is it a permutation of something? No, it's just a array, I guess. Yeah, 3 4 5. It's giving some kind of Dusu kind of vibe. Minus y minus 1. If such integer does not exist, output -1. Non-decreasing order. It's already sorted. Is it that's why? In the fastest case, no matter how large k is, you can always sort a into non-decreasing order, not performing any operation. Okay, it's running. Okay. Determine the if such an integer does not exist, output -1. It means if that's infinite or something. Yeah. So 1 4 2. Sorted list is 1 to 4. So they can be swapped at 2 moves. It's actually giving me some DSO vibe. Let's see. Let's have 1 5 6 9 3. Okay, if I sort 1 3 5 6 9. Okay, so I'm saying 5 and 3 are connected. Largest swap, yeah. Then five and 6 connected. Okay, I have to swap 5 3 here. Then 5 will gonna be swapped with 6. Then 6, yeah, 6 then we're gonna be swapped with 9. What's the minimum difference? Minimum difference is 1. 1 1 4 5 1 4 1 1 1 4 4 5. Okay, so this value, those all values are connected. 4 connected to, no, this 4 is connected to 1, 1 is connected to 5. So I have to swap. So I have to swap 4, that's 3. Then I have to swap 4 and 5. 4 and 5. Okay, I can do infinite number of swaps actually. If I swap this two, no, it doesn't make sense. Okay, so it's the place of, if I swap 5 and this one at first, it will gonna give me 4. Then if I swap with 4 and 1, it will give me 3. So I'm thinking something, I wanna swap the largest value with the smallest one at first, I guess. So 3 not in position, 6 all of them are not in position, so I have to swap the largest with the smallest one who is not in the place. So that's 6, 6, then the next largest, next largest is 3 again, then the next largest with the smallest one, 5, 3, so answer is 2. I'm guessing this kind of stuff. So if I do this kind of swap operation, actually what is gonna happen? Smallest one, if there isn't the smallest one, let's say it has 5, it has 5, let's say it has 5 and 3 was somewhere here. Let's think another example. 1, 5, 9, 6, 3, 5, 6, 5, 9, yeah. So largest value which is not in its position is 9. So if it sees 3, is it useful? Yeah, it's actually useful because those share distance, because it's 3's position. Let's no, it's not 3's position. Okay, so for 9 everything is greater than or equal to, so I'm gonna skip. For 5 same, for 3 same, for 6 there is option, 3 is, or I think I should start from the beginning. For 5 there is a value which is smaller, 3, so 3 for 5, as small as or as large as possible. For 5 I can swap that one, so I'm using 2, 3 and 5. Let's see. So here's 3 and here's 5. For 9 the minimum value is 5, so by swapping them I'm getting 4. That's 9. For 6, what's the largest one? Smallest one, that's 5, so 1 operation. For 5 then it's 6, for 6 it will gonna skip. For 9 it's 9 still, so skips, answer is 1 only. Let's try the example, give an example. 1, 1, 4, 5, 1, 4. For 1 all okay, for this one also okay. For 4 I get 1, so by swapping them I get 3. Yeah, I get 3 and 1 is here, so 4 is here. For 5, okay, it's not optimal way of solving it. I'll swap something like largest value with any swappable smallest value in its previous. Largest, that's the largest, 5 swap, So that's 5, that's 1. Then this will gonna be swapped. No. Yeah, C has less solved, so let's give it some time. One, 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 4, 4, 5. Okay, so I want 5 in this position. If I put 5 in this position, the value automatically becomes 1, so it's not optimal. So if I put 1, that's not so good to put 1 here, but how I'll know? Five wanna goes to this position, 4 wanna goes to this position, 1 wanna goes to this position, and this 4 also goes to this position. So they are swappable in any manner, I'm guessing. So 1, 4, 5, 4, 4, 5. So 1 can be swapped in any way. One is the minimum value. I'm saying 1 can be swapped with this one. So 1, 4. So 5 can use 1. So 5, 1. This 4 can be swapped with this one. 1, 4. So that's that. But what if I have something greater, like 10 here? So 1, 4, 4, 10. So this 4 can use 6. This 4 also can use 6. And this one can use 9. Let's put something else. Let's put more values. For 6 and 7, let's put 8. Okay, so for 6, 1 is optimal because I can get 5. For 4, 4 is optimal, I can get 4. Yeah, so let's try this example. 8, 4, 6, 1. Okay, so for 6 I want to use 8. Sorry, I want to use 1. For 6 I want to use 1. For 6 I want to use 1. Yeah, they can be used. So 6, 1. For 8, 8 also wants to use 1. So it should be my first choice. Okay, for 6, it's actually on its place. So 6, 4. So if I do one swap, it will gonna be 8. It will gonna be 1. So 8 has used 1. Then for 6, I wanna use 1 actually. Okay, and 4 wants to use 8. If I switch 4 and 8, 8, 4, 8, 4, 8, 4, 8, 4, 8, 4, 8, 4. and 4 wants to is 1. Okay, it's going in a loop kind of stuff. It's not 8 4 1. So 8 is connected to 1, 1 is connected to 8. Those are closed loop. Those are connected to those are also closed. Let's tangle them up. 1 4. So 8 is connected to 4, 4 is connected to 6, 6 is connected to 1. Okay. 8 is connected to 4, 4 is connected to 6, 6 is connected to 1. Yeah. And 1 is connected to 8. So 1 4 6 8. 1 4 6 8. Every value is connected to everything else. There's two options. I can use one value for everyone. So for this value I have 4. The value is 3. Value is 5. The value is 7. So answer is 3. And for 4 this is 3. Yeah, it's optimal to use the largest or the minimum. It's 7, it's 4, it's 2. So answer is 3 actually. So if I wanna use 8, it will gonna be 8. So swapping by 8. Okay, 8 wants to go to here, so that's obvious. So 8 4. Let's write the previous zeros. So yeah, then 1 goes to here, so swap 8 and 1. Let's put 8 again here and 4 here, and 1 wants to go there, so 1 goes to there, 8 comes to here, then they swapped. So 1 4 8. Then 6 wants to use 8, so 6 goes 6 4 goes there, 8 goes there, 6 comes here. So I can use, yeah, so I can use one value in a large distance, I guess. Okay, I hope this solution will work. Oh, there is, yeah. It's like that. Okay, I want to see the components, how are they connected. Okay, so I'm saying 8's position. I have to find the position of 8. So 0 1 2 3 4 5, position 5. So I'll go to position 5, C4. So I'm saying 8 4, same block. Then going to this 6, so I'm saying 6 is 4, so 6 1 is same block, 6 1 same block. It will gonna be a set. 8 goes to 4, 4 goes to, okay, 8 goes to 4, 4 goes to 6, 8, 4, 1, 4. Yeah, so 1, 2, 3, 4. So 6 is 4, so 8 goes to 4, it's visited. 8 goes to 4 goes to, and 4's value is 2, so it goes to 8, and 8's value is 8 has 2. This position is for 2. Okay, I did something wrong. 8, 6. 8's position is 4, so goes to 4. 4's position is 2, goes to 2. 6th position is 3, goes to 3. 1's position is 1, goes to 1. So yeah, loop is done. Okay, it's a single value can have multiple there can be multiple values. There can be multiple values. 10 to the 4. Okay, there can be multiple values. 1, 1, 4, 4, something, something, something. Actually, going to both 5 is optimal, I guess, because I'm increasing the values. If I have more values, I have more option to swap actually. Should I use map or something else? How many position that value has? I have to store that actually. mp.count val I not count. Vector vv pin -1 dot pushback I, and also have to create a vector in that place. Most probably for this one. So I'm saying if that's the case, So I'm clearing, I'm actually pushing the temp, then clearing the temp, then renaming the prefix, then pushing the current value, and doing that. Else, let's not do else, just push the current value, push the current value. Oh yeah, okay. Pushing the current temp, then clearing the temp, resetting previous, inputting new in the map. Yeah. Then in the end, vv dot push back temp. Yeah, that should be good enough. Still 6 for vii. There shouldn't be a -1 now. Yeah, everything is printing fine. So now if that's not visited, I'll do something. If that's not visited, then I'll call a TFS function, I guess. First n is 25. If not visited, long I. Okay, I have to pass so many stuff. I have to pass also VV. Okay, I have to pass the vector, pass the current value, and yeah, also pass the set. So set yeah, if okay, let's not make it global function. Okay, if not visited, I'll do something like go to the next value, query, fast in fast out kind of stuff, long queue. Okay, I'll insert in set, also insert in kiwi. Push v. Q dot push I, and this is while Q dot size, Q dot front long x equal to Q dot front, then Q dot pop. This should be x, this should be x. So I'm doing a lot of stuff here. And for auto v st cout v cout handle and st dot clear. Okay, let's see example 1. Where's that example? 1 8 6 1 4 3 6 total 6 168 by 168 1 1 1 8 6 1 4. So 1 1 1 4 6 8. So 8 connects to 4, 4 connects to 6, 6 connects to 1. Where's 4? 1 2 3 4 5 6. Yeah, 6 zeros. Where's 1? Cout here of x. Weird. 4 is 1 6. All of them are in this. Okay. That's okay. There's a problem. Should I state or answer should be actually here. One 6 8 4 is in a different place. Cout I. Cout x space arrow x. Okay, I got tangle for 1 0 1, then 2 2 2 2, and 3 4 1. 4 is 1, so 4 also should be So I get 8. Let's print this one. Okay, 4. I'm printing V. V is the value, and those are the connected components. Okay, 4 is connected to 0, 1, and 2. 0, 1, 2. So 1 has 0, 1, 2. Okay, 4 is the index. It's the index. Did I store index? No, I haven't. Okay, 1 has 0, 1, 2. Makes sense. 4 has 3, 4. 3 and 4. 4 is 3 and 4. Why 3, 4? 8 has 5. Makes sense. 4 has this one for its own position. Why also 4? Why also 4? Yeah, I got all the point, but 4 is 3, 4. 4 has 0, 1, 2, 3 for sure. 4 is 3. 4 is only 3, not 3, 4. So something is still weird going on. One, 1, 4, 6, yeah. Previous or fixed, and I'm saying if previous not equal to something, then push back push back the first value, clear that one, then previous equal to current value. I'm setting new index equal to 1, cause yeah, the index plus plus. Okay, previous equal to value. Yeah. Okay, 4 is 3, 6 is 4. Yeah, that's nice now. need max and min. Can I select any middle part? 1, 3, 4, 5. Can I select any middle value? 8, 6, 1, 4. 1, 4, 6, 8. The middle is not always optimal. I want the largest distance. Only 2. Okay, I have the segments. One, 4, 6, 8. What if the distance was 1, 4? A huge distance. 10, 12. If I choose 1, 9, it's 13. For 4, it's only 3. But if I choose 10, let's say it's some 10 and let's say it's 15. So ten and 4 chooses that one. So distance from this value. One, 4, 10, 15. Minimum is 3. If I choose this value, it's 3. If I choose this value, it's if I choose this one, it's also 3. If I choose this one, it's 6. If I choose this one, current value and future value, I need 2 values. Okay, if I choose this one, 5. So optimal is 6. And that's 5, so 5. Optimal is 5. So x equal to is cycle I minus 1. If I less than n minus 1, x equal to minimum of x comma cycle I plus 1 I plus 1 CY0 cycle I, and after every loop max v, let's make it minus, equal to max of x comma max v. Okay, then answer, what problem is this one? E. And second minimum of what the heck I'm doing. I'm just confused. After every while loop, where the while loop is ending. While dot size, there's the for loop. I'm clearing everything. So it should be here. Answer should be outside actually. And second minimum of yeah, answer comma max v 118. Ouch. Answer. Okay, it's giving a lot of weird output. Cycle I minus 1 not equal to cycle I plus 1 I. And cycle I plus 1 not equal to cycle. Okay, I'm still wrong. I'm sure I'm overcomplicating stuff. Oh, those both are I. J. Also, the code is not n square. It's n plus n. It shouldn't be n, it should be cycle dot size. 1468. That's okay. So that's that. Something x equal to infinity, j not equal to 0, and cycle minus 1 not equal to, okay, those will not be same, never. Okay, then I'm saying x equal to cycle j minus cycle j minus 1. Yeah, then I'm saying if j plus 1 greater than something, then x equal to minimum of x comma cycle j plus 1 minus cycle j. Yes, that's correct. See out x. Yeah, and answer equal to minus 118. So max equal to is max of all of them, and answer equal to is minimum of all of them. So that was correct. See out mx v. mxv is 3. Why it's giving me 8? Max is 3. That's correct. Max is 3. So got 3. So answer equal to answer comma minimum of max. So why it's not giving me the minimum answer? It's giving me minus 180. Oh. Two. It's giving me 1 somehow. Okay. 1, 1, 2. This one is the case. I got cycle of 1, 2. Cycle of 1, 2. Cycle of 3, 5. Cycle of 4. I think 1 and 2, 5, 4. Oh, okay. $4,000 solve. I don't think I can solve C. You are given two non-negative integer x and y. Find two non-negative integer p and q such that p, x and q equal to 0 and x minus q plus y minus, x minus p plus y minus q is minimized. Okay, those are opposite of each other at least. 1 0 0 1 something opposite. Okay, and x minus p, what is x? Two integer x and y. Okay, I have x and y. So if I have x and y, difference from x, okay, those are between x and y, I guess. Yeah, it's saying those are between x and y. If those are between x and y, those are optimal, I guess. 1 1. I have to find p and q. P and q. 7 1, 7 11, 7 11. Okay, let's take a random value. 1 1 0, so 1 0 0. 1 0 0 is 8, so 7 and 8 is also optimal, because I can do 7 8 0 and 11 8. So, yeah, 7 and 11 8 is 3, and for given answer is 6 9, so it will generate 1, and 9 will generate 2, so that's same as 3. If those are between 0 1 1, let's say it's not in the limit, this value is not in the limit, so what are we going to do? I need any opposite value actually. Yes, I need any opposite value. Any kind of opposite value is good. Let's say I have the number line. If I choose something outside the number line, in extreme max, if I choose something at extreme max, extreme future, this value is fully added. The minimum value, if I add something in future, what is gonna happen? If I add something in extreme end, it will just decrease this previous sum and all the, okay, I have to put any value with the minimum difference, and that will decrease all value up to that point, let's have 2 3, 2 3, and I have 5 7. For 2 and 5 I got 3, and for this one 4. More difference is bad, so I need any closest opposite value. Any closest opposite value. First option is between them, so x and y can be really high, 10 to the 9. I have to find any value between them with the opposite values. If that's not possible, I'll do something really close, maybe digit TP, maybe. What's the limit of 11? 11 is 8, 9, 10, 11. 1 2 4 8, yeah. So I'll try to find any opposite value. If I cannot find any opposite value, 1 1, I'll take the first value and take its opposite value, 1 0. Opposite value. So I have 0 0 1 1. In the opposite side I have 1 1 something. If I see any difference in those, I can definitely say there is a value, opposite value exists. If that was 1, no. It is non-negative integer. To find to non P and Q such that something can P and Q, you have to give an okay, 1 1, so I need 1 0 0. Does it matters if the smallest value, let's see, gives 1 2 3 7 something something something. That's 1, makes sense. The same output. Then 3 8. Eleven 4. One, 2, 8 minus 1, 2, 3, 5 and plus 0, so it's 5. 3 2 1. Okay, today I'll get a huge minus. C, I should be able to solve C. Let's suggest rating C. I don't feel like reading any of them. And they looks really hard. Okay, I don't feel this contest anymore, so